Good evening, everyone. I'm CV Sharma back with another video. So, a particle is released from rest from a tower of height 3h. The ratio of times to fall equal height h, that is T1 is to T2 is to T3 is given by. So, what is the answer for this? So, the answer is B. How it has come, we'll see now. Now, to understand this, let me take the whiteboard and then I'll explain here. The solution is anyway here. So, but they solved it in a very simple way, shortcut, but the answers are not that straightforward. But anyway, I will let you know how exactly it will be resolved. So, here you have the object which is falling from a height of h. Actually, 3h is what is given. 3h is the height. And now at equal distances, but the equal distances are not covered at the same time intervals because it is accelerating because of the gravity. So these are the three equal distances. Let us break the motion into three equal distances. This is h, and this is h, and this is h. And let us say this point is A, and this point is B, and this point is C. And when it reaches B, it will hit the ground. So that is h plus h plus h, that is 3h. And now to cover these heights, the times are different because object is accelerating. So the time is different. And now how to calculate the ratio of the times? That is a question mark. So for the first height h, it took a time of t1 and the initial velocity is 0. So h is equal to s. We'll use the equation s is equal to ut plus half at square. Right. And now the u part is 0 because it is downward motion. We can write it as minus h. And then the acceleration due to gravity, that is minus g. So we substitute. So minus h is equal to minus half gt square. So here the time it took was t1. So half g t1 square. So minus gets cancelled to become plus. Both sides, if it is minus sign, then you can make it plus. So from this, which you can write t1 square as 2h divided by g. This you can write. And now similarly, for the second thing, what we can do is now A to B we calculated. And now we see A to C. So A to C calculation refers to the height of 2h. This is h, and this part is h plus h is 2h. And now it took a time of t1 plus t2. So we write the equation half g t1 plus t2 whole square. And now t1 plus t2 whole square happens to be 2 into 2h, right? 2 into 2h divided by g. This what is t1 plus t2 whole square. And now similarly, for the height of 3h, we can write t3 square happens to be 2 into, this time it is 3h divided by g. So that's not t3 square, sorry. That is the total time it took was like t1 plus t2 plus t3. t1 plus t2 plus t3 whole square. That's what it is. And now let us take the ratio. If we take the ratio, t1 square is to t1 plus t2 whole square is to t1 plus t2 plus t3 whole square. So this is what you have. And now it happens to be, right? So you have 2h by g is to 2 into 2h by g is to 2 into 3h by g. So this is what we have. And now we can cancel this 2h by g part throughout the ratio 2h by g, 2h by g. When we cancel, we end up with the ratio 1 is to 2 is to 3. After now, it's fine. We got the ratio 1:2:3. Now what we have to do is we want, but what we got, we want the ratio T1:T2:3, right? But what we got is T1:T1 plus T2:T1 plus T2 plus T3. So let's write this. T1 square is to T1 plus T2 whole square is to T1 plus T2 plus T3 whole square. So all things together is 1:2:3. And now if I take out the root, I take out the squares. That is, if I take out the squares, that means I'm removing the square here. Then it becomes T1 plus T2 plus T3. It becomes like square root of 1, that is 1. Square root of 2 is √2. Square root of 3 is √3. And now what I want is when you have it like this, you can write it as, so T1 is equal to K, T2 is equal to √2 times, sorry, T1 plus T2, I can write T1 plus T2 happens to be √2 times K, and T1 plus T2 plus T3 is √3 times K. Like this you can write, because if you have a ratio like x is to y is to z, if it is like 5:6:7, I'm just giving an example, then x can be written as 5K, y can be written as 6K, and z can be written as 7K, where K is GCD of XYZ. So the K becomes the GCD of XYZ, which will get cancelled when you pick up the ratio. And now when you have this, I have T1, I can find T2 from this. So instead of T1, let us put K. So K plus T2 happens to be like √2K. So I can find T2. T2 happens to be √2K minus K. So that's √2 minus 1 times K. This is how I get T2. And I know the value of T1. I know T1 plus T2 is equal to √2K, right? So that itself I can substitute here. So √2K, right, plus T3 happens to be √3K. And the T3 can be founded as √3 minus √2 multiplied by K. So now let's take the ratio again, once again, T1 is to T2 is to T3. And the K becomes GCD of these three numbers, right? So we have √2K is to √2 minus 1 multiplied by K. Sorry, √2, I did a mistake. That is, T is K itself, T1 is K itself. So you have K multiplied by √2 minus 1 multiplied by K is to √3 minus √2 multiplied by K. This is what you have. And the K can be cancelled out. So you'll end up with the ratio 1:√2 minus 1 is to √3 minus √2. So that's the required ratio what you want, hence the answer. So I hope you understood how the solution is coming for this particular question, and thank you all. Thanks for watching the video, and I hope you like it and share and subscribe and with your friends, and thank you all. Thank you very much. Thanks for watching the video once again, and please do like and subscribe.